So let's take a look at, this is for the Santa Fe Grill. This is for the reasonable prices. Now, for reasonable prices, let's say that the Santa Fe Grill owners, they think their menu prices are reasonable, and people would assume that. So this scale went from reasonable prices from strongly disagree, which was a 1, to strongly agree, which was a 7. Okay. And if you look, the mean was 4.47. So average would have been 4. It was a little bit more than average. So they a little bit more agree that it's a reasonable price, but still kind of right there in the average. Now, what we can do here is, let's say our null hypothesis in this case is going to be that the mean equals 4, that it's average. The alternative hypothesis, what we are trying to prove, is that the mean does not equal 4, okay? And we're going to do this at a certain level of significance, the kind of how much error are we willing to accept? And usually we do that at a 0.05, which means 5 tests out of 100 would be incorrect. Now, if we look at this again, we see that the mean was 4.47, but what we want to know is it's statistically different than 4. We know that it's numerically different, but do we have enough evidence in our sample to prove that the population mean is different than 4? And if we look down here at the one sample test, our t-value is 5.4, and our level of significance is 0.000. That's a really great level of significance. That means there's very little chance of us being wrong. The mean is different than 4. We could say that the mean is slightly higher than 4, so they have a little bit more reasonable prices, but there's still some room for improvement here, and we don't want to forget that. So to do this test in SPSS, you would have gone up to the top to analyze, clicked off on compare means, and done a one sample t-test. That's how you will get to this, and I'll walk you through that a little bit later in SPSS. Now, when we look at bivariate statistics, we're testing hypotheses that compare the characteristics of two groups or two variables. So this can be a lot of fun. There are 3 types of bivariate hypothesis tests that we do: chi-square, t-test, and ANOVA, or analysis of variance. Now let's start with cross-tabulation, because this is kind of where everything gets together. The purpose of cross-tabulation is to determine if differences exist between subgroups of our total sample. So it's useful in examining relationships and reporting findings for 2 variables. And we're really looking to see if differences exist. And we're using a frequency distribution of responses on 2 or more sets of variables. Now, the chi-square analysis enables us to test whether there are statistical differences between the responses for the group, and that's why we love chi-square. Now, there's some examples of questions that can be answered using the chi-square analysis in your book, and I just want to look at a few of them. One of them could be, is internet usage heavy, moderate, and low, way to classify people into groups nominally, related to educational levels: elementary, middle, high school, some college, college degree, and postgraduate work. You could also look, is brand awareness unaware or aware, related to geographical area in which the individual lives: North America, Europe, Asia, Africa. These are all different ways where you're looking at 2 ways to classify people, 2 ways to name them. They're both nominal data, and you're looking to see, is there a relationship between them. So let's look at a cross-tabulation, and this is gender by ad recall. Now, I'm going to be absolutely honest with you. Whenever I look at a cross-tab table, I have to take the interpretation of it very slowly, because it's really easy to mess this up. So you'll notice that we've got up here our 31st variable is ad recall, and they either did not recall the ads or they recalled them. And over here is gender. So those are the 2 variables, bivariate, that we're looking at. Here's male and female. And over here is a total column, and this is a total row. So keep that in mind. Now, for those who do not recall the ad, for the whole sample, everybody who responded, 270 did not recall any ads. 135 recalled ads, for a total of 405 respondents from the entire sample. So we had 405 respondents regardless of gender. 135 remembered the ad, 270 did not. That means that about 2/3, or 66.7% of the sample of 405 people, did not recall the ad. And 33.3% of the people who responded did recall the ad. Now that's total, no gender taken into consideration. These two columns break that down into gender. So out of those 270 people, 188 of them were male that did not recall the ad, and 82 were female. Okay, so the percent of the total here, 46% were men that did not recall, 20% were females that did not recall. Okay, but if we want to look at it within gender, okay, 71.2% of men did not recall the ad versus 58.2% of women. So this is where you have to really think about what it's saying. Now let's drop down here to recall the ad. We've got 135 that did, 59 of which were female and 76 of which were male. We've got, of the total, 18.8% of the 33% that recalled the ad were male and 14.6% were female. When we go up here and we look at gender, 41.8% of females recalled the ad. And if you add this number to this number, you get 100. 28.8% of men recalled the ad. 71.2% did not. Add those up, you get the you get 100 as well. Now, out of those that recalled the ad, 56.3% were men, 43.7% were women. Out of those that did not recall the ad, 69.6% were men, and 30.4% were women. So you should see that when you add these across, you'll get 100%. So if you look at this, it's a little bit confusing. You're thinking, oh, well, it looks like more men recalled the ad than females. If we look here, up here, though, it looks like more men did not recall the ad. Well, we have to look at, hey, guess what? There were significantly more men included in the survey than women. There were 264 men out of the 405 and only 141 women. So now the question is, hey, okay, given that, is there a difference? And the higher percentage of males in the recall ad group is due to the fact that more males than females were interviewed in the study. And this bottom row tells us that. So the next thing that we need to do to find out if there is an interaction is to run that chi-squared test. So if we want to assess how closely the observed frequencies fit the pattern of the expected frequencies, we're going to use the chi-squared analysis. And I love this one because what it does is it looks at to test for statistical significant differences between the frequency distribution of two nominally scaled variables in a cross-tabulation table. So it would be looking to see, hey, does gender play a role in ad recall? Okay, that's what the chi-squared would help us test. And remember, it's only about relationships between nominally scaled data. If you have something that's interval or ratio, you can turn it into nominal scale data. You can use the transformation tool in SPSS to change that, but you're going to have to do that before you do anything else. And remember, this chi-squared thing is looked at as a goodness of fit. Now, the chi-squared value tells you how far the observed frequencies are from the expected frequencies. And so the larger the chi-squared is, the more likely it is that the two variables are related, okay? And so we're looking at this fit. How well does something fit what we expect? So to kind of give you an idea of what that means, let's go back over to here. So if we look overall at the sample, 2/3 of all respondents did not recall, and 1/3 of respondents did recall. So we would expect that 2/3 of men and 2/3 of women would not recall, and 1/3 of the men surveyed and 1/3 of the women surveyed would not recall. So we take that 264 men, we take 2/3 of that, and that would be the number we'd expect in the do not recall cell. And 1/3 would be the number that we would expect in the recall cell. And what chi-square does is it looks to see, hey, is that what happened? And if it's different, is it statistically significantly different? So, and remember, the larger that chi-square number gets, the more likely there is that there is a difference. To do the chi-square test in SPSS, you're going to go Analyze, Descriptive Statistics, and then Cross-Tabs. You then want to put in your variables and click on the Statistics button and the chi-square box. Then you'll hit Continue. Next, click on the Cells button and the Expected Frequencies. And then you'll get total frequencies as well, and then you can execute the program. I'll show you how to do this. And when you get an output, you want to look and see what is the Pearson chi-square coefficient. And if that number is high enough, you'll look to see the significance level. And if it is below 0.05, and 0.000, by the way, is below 0.05, you can reject the null hypothesis and say that there is, with a high degree of confidence, differences between genders, and add recall. And we're going to look at that one. That result is not in your book or this PowerPoint, but we'll look at it when we do SPSS, I promise. So let's look at comparing means between independent versus related samples. Now, independent samples are two or more groups of responses that are tested as though they may come from different populations, okay? And it could be the result of interviews with male and female drinkers of coffee, if that's what you're looking at. Related samples, this is where two or more groups of responses that originate from the same sample population. You could also compare the average number of cups of coffee consumed per a day by male students with the average number of soft drinks consumed per day by the same sample of male students. So you're looking at the same sample, same population with related. With independent, they're two different populations. Now, in a related sample situation, you often will be looking at a paired sample where it has the same unit of comparison. And this is where you would do a paired sample t-test.